25 TZ1 paper 1, and this is HL. Alright, so we do have some SL questions that maybe we'll cover later in a bit. But for now we're doing HL, and the SL questions are also part of these. SL also there, so definitely stick around for just those, and you can skip through or even learn a bit about the HL content as well, as it does help. Okay, so we just speed run through all of these and check our answers quickly. So let's go. Instantaneous velocity is defined as our rate of change of position, right? Now, this is, again, we're speed running, but I'll just give you a quick, do drop in the comments if you need any specific questions revisited, and I will make a specific video for that and drop it right there for you. Okay, so this is displacement over time taken is our velocity, but it will be average velocity, right? Average velocity. Rate of change of position, that is our answer. Distance moved divided by time taken, that's our average speed. Rate of change of distance is our speed, instantaneous speed. Yep. And so hopefully you guys know the difference. If not, I think I did already make a video for question 1, so do check that out. Number 2, acceleration of an object. And so B is our correct answer. Let me check. Yep, B is correct. Okay, maybe I'll check it at the end so that we don't reveal everything. Okay, question 2. The variation with time t of the acceleration a of an object is shown at t is equal to 0. The object is at rest. Okay, so we have rest, and its accelerating speed of the object when t is equal to 8. Now we know it's at rest, so v is equal to u plus a t. Sorry about that. And u is 0. So v is equal to, we're talking about the speed at 8, so v at 8 is equal to the acceleration, which is actually changing, right? Our acceleration is changing, so we need to find our average acceleration, or we can write it like this, and that is, now we can do a calculation and we can sort of have and things like that, but the best way to do this question is to understand that the area under the graph, right, is our velocity, right, or accumulated, essentially. And so what we have is at 8 seconds, we find the area, and we get v is equal to half base into height, right? 8 times 8, and that is 6432. Answer is B. And so what we could also do is find the average acceleration, and that would be 4. So we can do 4 and then do the AT thing. So that would be v is equal to average acceleration times time is 8, and that is also 32. So that also works, right? But this would be our average acceleration. Okay, hopefully that's clear. Next is a force acts on a cube of mass m that accelerates upward along a vertical frictionless surface. The magnitude of the force is F, and it acts at theta to the vertical. What is the magnitude of the acceleration of the cube? So what we have is our weight of the cube, right? W. We have, there's no friction. We have an acceleration upwards. Okay, acceleration is upwards, so we have a net force. And what we have, sorry, we don't need to write that net force, but we can show this is our upwards force, and that is Fy, let's say, right? Fy is equal to, this is theta, cos, F cos theta, right? Hopefully you guys understand how I got that. Simple trig, and oops, what we should have is, sorry about that, F cos theta, that's our y minus our weight, that is mg, is equal to ma, right? Because we have an upward acceleration. And so our acceleration is just F cos theta minus mg over m. Right, so that is that A? Yep, that is the same. So our answer is A. No need to even look at the other ones. You can go, a sphere of density P and radius R rests on the bottom of a tank of water. The buoyancy force on the sphere is F1. The sphere of density 2P and radius r2 is at the bottom of the same tank. Buoyancy force on the second sphere is F2. Okay, so what we have is different density of the sphere. Again, the important thing to note about our buoyancy formula, Fb is equal to EVG. This is the density of liquid, right? Okay, and this is the volume displaced. Now, volume displaced is also the same as the volume of the sphere itself, right? So we can just say that is proportional to our volume, which is equal to 4/3 pi r cubed, I believe, right? And so proportional to this. And so what we need to know is the second sphere, F2, has a radius of r over 2. So let's calculate that of the second sphere, F2. This is F1, let's say. Or F1 is proportional to this. F2 is proportional to 4/3. We don't need this. We can just say proportional to r cubed, right? This is a constant. So if it's proportional to r cubed, we have r over 2 now. So r over 8. This is r over 2 cubed. That is 2r cubed over 8. Right, so we can see that it's 1/8 of that. So f1 over f2. So that would be, let's say, r cubed. Let's just write that divided by r cubed over 8. Right, and that is equal to 8, right? Hopefully you know how to, that the 8 just comes up, right? We're dividing by a fraction. And C is our answer. We can check that later. Satellite undergoes one circular orbit of the Earth every 24 hours. What's its angular velocity of the satellite? So W is equal to 24 hours, so 2 pi over T. T 24 times 3600. 60 times 60, right? 60 minutes, 60 seconds. And times, we already multiplied by the hours. So I'll just bring my calculator, and we get 2 pi divided by 24 times 3600, and that is 7.3. You guys can calculate that on your own, and you should get around this much, right? 7.3 times 10 to the negative. And so our answer is C. An object of mass 5 kg is initially at rest. An impulse of 2 Newton seconds acts on the object. What is the final kinetic energy of the object? Okay, at rest, impulse acts on the object. So we have delta P is equal to 2, right? And that is also equal to mv. So what we can do is find half mv squared. So if this is equal to mv, or ke, in fact, I think we have a formula for k, p squared over 2m, I think. We can check that. I'm not using the data booklet right now, so all of this is straight from memorization. So definitely remember your formulas, right? That's why I'm able to do this so fast. So we know p is equal to 2, because the object is at rest, so delta p is equal to p. So 4 divided by 2m, so, or m is 5, so 10, and that would be 0.4. So our answer is A. Next is a system of moment of inertia I rotates from rest about a given axis. The angular acceleration A of the system is constant. Okay. Angular acceleration is constant, rotates from rest. What is the change in angular momentum when the system has made 4 complete rotations about the given axis? Okay, so what we have to know is our angular momentum is IW. Now we also know theta, right? So we can use our formula. Theta is equal to u squared. It rotates from rest, right? So w initial squared plus sorry, different formula. We can use, I'll just write it straight, plus 2s as, right? And a is our acceleration, s is our theta, right? So theta is equal to w final squared divided by 2 angular acceleration. This is, sorry, that is what we're trying to find. So what we have is actually, so that is exactly what we needed anyway. All we have is, this is 0 by the way, so 2 theta, right? And theta is 4 complete rotations. 4 complete rotations is 4 times 2 pi. That is equal to 8 pi. So that is to acceleration, 816 pi. And that comes out as 4 root pi. Now we just have to bring it into this formula. So sorry, where did the a go? Yep, forgot the a, the acceleration. And so that is what I have. And our answer is this. Right, maybe let's clean that up. Okay. And so this looks like B here, right? So this should be our answer. I followed all the steps given in the question, and we'll check that later. Question 8. Two small spheres, each of mass 10 kg or 8 meters apart, connected by a rod of negligible mass. Okay, the system rotates about an axis halfway along the rod. Okay, so this is the axis, right? Or sorry, it would actually be like coming out of the page, but we can't really visualize that. Halfway along the rod and at right angles to it. What is the moment of inertia of this system? Okay, 8 meters apart, so this is 4, this is 4. So about our axis, we have moment of inertia is our sum, sorry, y is, yeah, sum of m r squares. So all we have to do is m1, m2, and they're exactly the same, right? They're identical. So you can do 2 times m is 10, r is 4 squared. So that is 16 times 10, 160, 320. So our answer is B, right? We did this pretty fast. Now on to the next one, question 9. Observer X sees the spacecraft moving in the positive X direction at a speed of 0.5 c. Observer Y sees the same spacecraft moving in the negative X direction at a speed of 0.5 c. What is the speed of Y in the reference frame of X? Now for this, okay, what is the speed of Y in the reference frame of X? So we're looking at speed, speed x, y, right? Or let's say speed of spacecraft, let's call that s. So x s is equal to, in fact, let's set up multiple equations for the speed, because we have one in terms of x's reference frame, one in terms of y. Okay, so spacecraft. So what we can do is v or x, right? Let's say sx. This is our, let's call it a vector. And so we have a velocity of s with respect to the velocity of x, right? It's a relative velocity, and we have that formula in our data booklet. It is this, right? So this is the speed of our aircraft, and let's say that's a stationary reference frame. Then we have speed of the aircraft in x's reference frame, and this is the speed of our object in the moving reference frame. And that is what we have been given, right? And so this is just the way I write it down. It makes it easier for me. So this is one. Next one is, because we have 3 moving spacecrafts, right? Number 2 is same spacecraft moving in the negative direction at a speed of 0.5 c. So let's just first do this and then input our values. Minus vy, right? And that is equal to negative 0.5 c, right? So our y is in the negative x direction, and this is in our positive x direction. Okay, so that makes sense. Next is, what is the speed of y in the frame of x? Okay, so what we need to understand here is that this is the speed of s in the reference frame of y, speed of s in the reference frame of x. So what we need to find now is, this is our third equation, speed of y in the reference frame of x, right? So now all we have to do is simply use these to find a equation. And remember, this is special relativity. What we're doing here is Newtonian relativity. But this helps us understand. So this is what I always do. I always first use Newtonian, and then I can use special relativity if this doesn't work out, right? So we have Vy minus Vx is equal to, first we must take the negative of this, right? We must subtract this equation from this. And so what we get is Vs minus Vs cancels out. Then we get Vy minus Vx is equal to 0.5 c, right? This becomes positive. This is still positive, plus 0.5 c. So what we have is c. And now what we must understand is your relative speed cannot be at the speed of light. You can't have the relative speed of a rocket at the speed of light. A rocket anyway doesn't travel at speed of light. So now we must use our Newtonian output to support our relativity equation. And we have a relativity equation that looks something 1 minus v, let me check the data booklet. I do have to take it out for special relativity. Yep. uv over c squared, right? Yep. So now we have a negative here. So that just becomes, that is exactly what we had here, right? This is the exact same as this. And what we have down here, again, we have 1 negative, so that becomes positive 1 plus, this time it's special relativity, so we actually need to multiply these, right? As you can see here, so 0.5 times 0.5 c squared divided by c squared. And what we have is c divided by 1.25, right? 0. Yeah. And that gives us, or 1 divided by 1.25, that is 0.8, right? Yeah, you guys can calculate that. And so our answer is B, and that makes sense, right? You cannot have something faster than the speed of light, especially in relativity, and C does not make sense. That assumes you used Newtonian relativity, and 0 also does not make sense. So honestly, even if you didn't do all of this, the only guess I would make is B. So I mean, it's a guessing game sometimes. Okay, block of ice, mass m, is at melting point. Placed on the top surface of the ice remains there. Okay, specific latent heat of fusion. What mass of ice melts? Okay, so we have Q supplied by the water. to the ice to cause the ice to melt. Okay, Q supplied by the water is mc T, right? It's at melting point, so that's 0. So there's no delta T, it's just T. And then we have that energy is then used to melt the ice, right? We're trying to find the mass melted, so we just equate it to ml. That's our specific latent heat of fusion, right? And so all we have now is actually we need to understand that there's a difference between these two, right? So ml, okay, and so massive ice. So m is equal to mc T over big M. Sorry, small m. Sorry, L, right? Yeah. Okay. So this only looks like A, so that's our best answer. Now, what is the primary cause of the enhanced greenhouse effect? Primary cause, like I'm thinking, students will be confused between these two, right? But the correct answer would be burning of fossil fuels, right? Because they're asking about primary cause. So, and they're talking about the enhanced greenhouse effect. So this is what's causing our greenhouse gas molecules to increase. We're having extra CO2, methane, all these gases, sulfides, nitrous gases, and water vapor as well, right? That's a greenhouse gas. The deforestation of rainforests, that's just reducing our sequestration uh sources, right? So these sequest CO2, but that's just reduced now. So it's not the primary cause, but it's a one cause. An ideal gas is held in a cylinder by a piston. The piston compresses the gas rapidly. Okay, so there's work done. That's what we need to see here. Work done, and that is negative, right? Because it's done by an external system on the gas. Average speed of the gas molecules increases because the gas molecules smaller volume available in which they can move. Nope, that is not why the speed increases. Thermal energy transferred from outside, it's compressed rapidly, so that's adiabatic, right? There's no time for energy to be transferred. They have received energy from the piston as they collide with it. That makes sense because there's work done. So that work done goes into increasing internal energy, right? We have Q is equal to, and this is negative, so delta U is equal to W. So that work goes into increasing internal energy, and that internal energy is our kinetic energy, right? Because it's an ideal gas, which is equal to nRT, let's say. Which is also equal to RKE, right? Sorry, internal energy should be 3 over 2 nRT. And next is make more collisions every second with each other. That might increase your individual kinetic energy, but your average speed of molecules does not increase. It's the average stays the same, right? Because your uh your collisions are elastic, right? Elastic collisions, since it's an ideal gas. Since ideal gas. So this is an important thing. So some of you may actually fall for this one too, right? Elastic since ideal gas. So momentum is conserved, right? And kinetic energy is conserved. So whatever kinetic energy is lost by one molecule to the other during a collision is gained by the other molecule and lost by one, right? So average kinetic energy stays the same, but individual molecules might gain kinetic energy. PV, which diagram represents a Carnot cycle? We need to have an adiabatic. First of all, you should remember that it's looks somewhat like this, so immediately I would go for C without thinking. But yeah, we would not have a Carnot cycle looking like this or this. This might be possible. What we want to see is actually exactly something like this. So actually just have this mental image of what a Carnot cycle looks like. And when you do enough questions, you realize that Carnot cycle looks like this. And it should be sort of automatic, right? Because you're having isothermal, and these adiabatic compressions and expansions, right? This is an expansion, this is a compression. Well, it depends on which direction. Three combinations of resistors are shown. The resistors are identical. Okay, so what we have is R, we have R, and we have R over 2 here. R over 3, so that is 4R over 3. This is 2R, 4R over 2, 5R over 2. And then here we have R, we have R, and we have R. Let's calculate this. R effective is equal to 1 over R plus 1 over 2R, right? Because these are taken in series. That means this becomes 2, this becomes 2, 3 over 4, 3 over 2R. So R effective is equal to 2R over 3. And so R total is equal to R plus this R plus whatever we found here. I just found this R effective. And so that is 5R over 3. Okay. And so that gives us total resistance, increasing resistance. So our lowest one here is this one, I believe. Right? Increasing. Okay, so our lowest should be first. So Q is first, then we have this is slightly larger, so that is R, and then P slightly is the largest. So that is D, right? Yep. 15 continuous belt 0.6 meters, travels at constant speed 2.5. Uniform distribution of charge on its surface. Okay, so across this entire area, we have 5. As the belt passes a point, all the charge is removed and is carried as a current in the wire. What is the current in the wire? Okay, so we have this area, and we know it's 2.5 per second. So let's calculate per second. Per second, we have an area of, right, and we want to find the area because we have a distribution of charge, right, per meter squared. So we need to find the total charge on this area. And that is per second, we have 0.6, let's say charge total is equal to 0.6 times 2.5 times 5 times 10 to the negative 3 because it's millicoulombs. And so let me calculate that. 0.6 times 2.5 times 5 times 10 to the negative 3. This is 7.5 times 10 to the negative 3. And that is total charge. Charge is removed, carried as current in the wire. What is the current in the wire? Okay, so per second, right? And what is our current? Current is charge divided by times, and we already have it in per second, so it's exactly the same. So this is our coulombs per second, and coulombs per second is our amperes. That is our answer. 16. A cube of side 1 centimeter has resistance between opposite sides 50 ohms. Material reshaped into a block of length 4 cm and constant square cross section. What is the resistance of the block between its square ends? So we have to use our resistivity formula, and that is resistance times area divided by length. Okay, so we can find the resistivity of 1 to then find the resistance, right? Because we have everything else here. So resistivity of this block is resistance, that is 50 times area, that is 1 by 1, that is 1. And then our length is also 1, since it's a cube, so 50. Then we want to find our resistance of 2, second one, of the second block. And we know the resistivity is the same material, so it should be the exact same material means our resistivity is the same. And so resistivity times length, that is 4 divided by our area. Our cross-sectional area is the same, right? Constant square cross-section, so 1. That gives us, oh, but it's saying constant cross-section, but that doesn't mean it's the same as this, right? It can't be the same because it's the same amount of material. So what we actually have to do is find the volume, right? Our volumes should be equal, so volume of 1 is equal to 1 should be equal to the volume of our second one. And what are our volumes? Our volumes are just our area, cross-sectional area, times our height. So area of 1 times 1 is equal to our area of 2 times 4, right? It should be equivalent. And so what we have is area of 1 over area of 2 is equal to 4. And now we can use that because what we know here is that, so this is, what we have here is resistivity is equal to resistivity times L2 over A2, right? Which are both different. And that is simply, let's see, okay. So what we want to be using here is actually the idea that it's A1 over L1. Okay, and so resistance is our P1 times this, right? And P1 is this, so that is 50. This is quite a complex question actually, if you do not think deeply enough. L2 over L1, and that is a 4, right? 50 times 4 times L2 over L1. L2 is 4, L1 is 1, so that's 4, and that is 200 times 4, 800. Okay, glad I realized this shape is different, which it should be. Yeah, so our answer is C. Next is 17. A mastering system oscillates with time period T1. Another identical spring is connected in parallel with the first spring as shown. The mass is unchanged. Okay, so we have 2 springs now. Our spring constant must then double, right? Because it's stiffer. So stiffer, K2 is equal to 2 times K1. Time period of oscillation for the 2-spring system is T2. What's T2 over T1? Okay. And we have our formula for time period is I think 2 pi root m over k. Let me check that just in case I'm not super confident about. Okay, yeah, that is correct. So then 2 pi t1 t2 is equal to this. And so what we have is root m over k times a root 2. So, well, whereas t1 is just without the 2, right? So in an exam, I wouldn't calculate that. I would just do this. And so it would just be root 2, sorry, 1 over root 2. So t2 on top, that means we have 1 over root 2 is our answer. Right? It's proportional to 1 over root 2. Okay. Question 18. A wave is traveling through a medium. The variation in time t of the displacement d of a particle in the medium is shown. What is the frequency and amplitude of the wave? Amplitude is clearly 5. Frequency is 1 over time period, and time period is 4. So 1 over 4 is equal to 0.25. But we have milliseconds, so that would be, if I'm right. Yeah, that it shouldn't affect, right? So it's just times 10 to the 3. So that would be 0.25 times 10 to the 3, and that's 250. Sorry, 10 to the negative 3. Yep. 19. Simple harmonic motion with frequency f. The distance between extreme positions at which the object is at rest is b. What is the speed of the object when it is halfway between its equilibrium position and its extreme position? So speed, they're asking for ke, and we know re k is equal to half m. I don't believe this is given in the data booklet, but we can easily figure it out, right, using our formula. Right, and x naught is our maximum, which is O, and we're saying at maximum, our maximum is b over 2. And we also have, we're talking about halfway between equilibrium and extreme, so that would be b over 4. So this is, let's just say, proportional to b squared b over 4. We have 16. So b squared over 4 minus b squared over 16. Now that is 3b squared. Sorry, 4. Yeah, it is 3. 4 minus 1, that's 3 over 16. Okay, so we did okay, they asked for the speed, and we calculated kinetic energy. In fact, all we needed to actually do was use our formula in the data booklet, and that is simply this, right? And it comes from this anyway. So all we had to do is just square root this essentially and multiply by 2 pi over t, or 2 pi f. And so I can just do this. Hopefully you guys know this formula, right? 2 pi f. This is 3b squared over 16, so that is 2 pi f 4, so half root 3, and we have b. So that gives us b. Hopefully that's right. Yeah, I think it should be, and we'll definitely check. Okay, how about we finish question 20 and then I upload this since it's anyway hitting 40 minutes. Then we'll get on to the next ones. Light passes through two parallel layers are shown. The refractive indices for light traveling between air and the medium are shown in the diagram as n1 and 2. What is theta? Okay, so what we know is this is 50, that means this angle to the normal, this angle to the normal, which is actually the same anyway, is 40 degrees, right? 90 minus 50, and so that's our angle of incidence. So n1 over n2, I think, is sine r over sine I, and that should be n1 over n2, 5 over 3, times 3 over 4, right, is equal to sine r. That is our theta, and I is our 40, sine 40. Let me just bring that there. So we have 5 over 4 times sine. Okay, need to change my calculator to degrees, sine 40. And then take the sine inverse of that. Theta is equal to sine inverse of 5 over 4, just showing you guys the steps, right? So sine inverse of that is 53. Okay, that's our answer. Yeah, so I'll just upload this now, and so hopefully you guys get an early review at these first 20 questions, then I'll get on to the last 20 questions. Hope all of these made sense. Again, if there's a specific question that you guys need clarification, do let me know. I ran through these relatively quickly, explaining not as much as I could. I can definitely explain more. So do let me know. I just want to make sure I'm not taking too much time and you guys can revise really quickly. Okay.